everybody. Let me welcome you in this regional training on understanding better microplastics and identifying how to address the issue. We are talking about better understanding because the issue of microplastics is indeed a very complex one and a rather new one. I remember that when in the late 70s we started discussing this and including it in my textbook, many people question if this is an issue at all, because they consider plastics as inert. So this training will have three actually sessions. This is the first one. And we are going to have with us important speakers, colleagues, and cooperators for many years, and among them a very close collaborator, Dr. Thomi Vlachogianni, but also Professor Fossi, Dr. Kaberi, and Dr. Ioachimidis, all of them very excellent scientists and the people who have worked for many years from different organizations. I would like to start by saying that the use of microplastics and the waste by microplastics as waste are very closely linked with the overall plastic pollution problem, which in turn is linked with the overall management of waste, both domestic and industrial. And on the different aspects of this issue, we have worked for many years, more than 10-15 years now, under numerous EU-funded projects. On many of the results of these projects, the WES, the present project of Water Environment Support, capitalizes. And to understand the approach, we need to emphasize that what we are doing is in the interface of science and policies. The policy framework of WES is characterized by three axes. The one is the European policies, and within these policies we have many initiatives and directives and important guiding documents, such as the EU Green Deal, the EU Strategy for Plastics and Circular Economy, the Single-Use Plastics Directive, the Marine Strategy Framework Directive, the REACH restriction proposal, and upcoming microplastics initiatives. We have, so this is, although it is North Mediterranean European, it to a certain extent it influences, it guides also policies in the entire region, used as a blueprint or a source of inspiration. The second axis is the one of the UFM, the Euro-Mediterranean cooperation, as expressed by the UF ministerial meetings on environment, climate change, and also the UFM 2030 Greener Med agenda. And the third is the UN body that actually brings together both north and south coasts and east and west of the Mediterranean, which is the United Nations Environment Programme and the Mediterranean Action Plan and the Barcelona Convention. And also beyond that, at global level, the COP22 all in the Mediterranean. Beyond that, all the COPs that either on climate change or biodiversity or the rest provide. Could you please mute yourselves? And within the Barcelona Convention, the COP of December 21 in Antalya, the program of work 21-22, the regional guidelines on measures to phase out single-use plastic items, and upgraded the regional plan for marine litter management in the Mediterranean. The WES, which is the framework of also of this activity, aims at protecting the environment and improving the management of water resources in the Mediterranean, trying to address country needs, enhancing capacities of administrations, but also of all stakeholders in partner countries to tackle problems related to pollution prevention and water efficiency. And as I mentioned already, the work of WES capitalizes on previous successfully EU-funded regional projects running for more than 10 years, such as the Horizon 2020 Capacity Building Mediterranean Environment Program, the SWIM program, the SWIM Horizon 2020 program, all of which were managed more or less by the same group. The partner countries are the countries of the south and east of the region. In alphabetical order, you see them there: Algeria, Egypt, Israel, Jordan, Lebanon, Morocco, Libya to a certain extent, and Tunisia. With a project of 9.5 euros running till November 23, perhaps extended for till 24, with a team led by me and key experts Susan Taha and Anis Ismail for water and environment, respectively. Lisa Papadogiorgaki, communication officer, and Dr. Emma Dudley, stakeholder engagement impact expert. The consortium is led by LDK consultants and includes MIO, the Mediterranean Information Office for Environment, Culture and Sustainable Development, the Arab Network for Environment Development, the Association of Cities and Regions for Sustainable Resource Management, the Agronomical SIHAM, the Agronomical Institute of Bari, three major consultancies, GAPA, Ramboll, and Royal Haskoning, and from UNEP MAP, the Regional Activity Center for Sustainable Consumption Production. The structure is of the technical assistance, capacity building and networking, includes a regional and a national component. The regional, we have around 20 regional activities, trainings, workshops, study visits, one of which is the present one with 3 sessions, with webinars and also coached peer-to-peer exchanges. The national ones are around 4 per country, 2 on water, 2 on environment. And we have national meetings, unfortunately, platform meetings of collaboration with all partners but unfortunately, these have been postponed due to COVID. The impact, we try from the beginning to build in the necessary prerequisites for that, and with the selection of the participants, but also with evaluations, with quizzes, exercises, evaluation after the meeting, but also with midterm results, online post-impact surveys sent to the trainees, and direct interviews with some selected trainees. And the three components, the three sessions, the one of today, as I mentioned, is to get a little bit deeper in understanding the issue of microplastics, amounts, types, sources, effects, approaches. And the other two, and the second, will get deeper into the political frameworks and taking into account that some have been. Could you please mute yourselves? Some micros are still open. Taking into account that some are intentionally introduced in different products and different practices, and some are not. So the two next sessions will elaborate more on that. The websites are there, and you can actually get through them, and also follow the social media. This is all for me at the moment, and I hope that we can have a very productive session today. And I would like to invite now Thomi Vlachogianni to take the floor and continue.
Thank you, Professor Skoulos, and welcome everyone. It's a great pleasure to have you here with us today. I see a lot of familiar names and faces, but also several newcomers. Just give me 1 second to share my screen. And I hope you are seeing it.
Perfect.
And
yes,
great.
It's okay.
So I just would like to kindly invite all of you to mute your microphones in order to ensure that the webinar will run smoothly. And also to kindly invite you to post questions in the chat, whether these will be in English or in French. And then we have a colleague who will help us translate the French, at least, questions into English, and we can then address them to the speaker. You can also indicate which speaker you would like to respond to these questions. And if time permits, at the end of the webinar, we might give the floor to some of you to ask questions live. So I just wanted to provide you a very quick overview of this webinar and module 1. Professor Skoulos already mentioned that this regional training consists in 3 modules, and today we will be discussing the problematic of microplastics, and some of you might already have heard some of the terms and definitions that will be presented here with, because you followed the previous webinars on single-use plastics. But in order for all of us to be on the same page and to be able to follow the different presentations and interventions, it is necessary to establish this common understanding on different terms and definitions. And basically what we will be discussing here with today will be the topic of microplastics pollution in the marine environment and how this problem is being characterized. We will provide an overview of the amounts, types, sources, and effects of plastics and microplastics in the Mediterranean Sea. Also, you will hear about different monitoring approaches, and you will get an overview of these approaches, but also through Cristina Fossi and Helen Camberi, you will obtain a more deepened understanding of specific monitoring approaches in biota, in beach sediments, and other marine matrices. And then, of course, we will have with us Christos Ioakimidis, who will present you the policy advances at the international and Mediterranean level. So just a couple of words about our trainers. Maria Cristina Fossi is a university professor and ecotoxicologist at the University of Siena, and she is a pioneer in microplastics research, in particular in studying the effects of microplastics in cetaceans. She's actually worldwide known for that, and she has been making a lot of cutting-edge publications and films, documentaries on the topic, and I kindly invite all of you to take a look, for example, in social media channels to see what kind of work she's doing. And she will be talking to us a lot about the effects of marine litter on biota and the best approaches to monitor and understand, to obtain a greater understanding of these effects. Then Helen Camberis is a researcher in the Hellenic Center for Marine Research. She's also a well-known expert on the topic of microplastics, in particular in studying microplastics in beach sediments. And her intervention will focus a lot on that topic. And Christos later on will join us. He's also a marine litter expert, and for the last decade, he has been working extensively on the topic, also through his position in the United Nations Environment Program and the Mediterranean Action Plan. And last but not least, most of you, I think, know me. I am also an environmental chemist and ecotoxicologist, and in the last 10 years or 12 years, I have been very much involved in wide-ranging marine litter-related projects addressing the entire management cycle of the problem, from monitoring and assessment to prevention and mitigation. And before we go into the presentations, in order for all of us to understand a little bit your background on the topic of microplastics, I would like to ask you to respond to a Slido survey. If you go to slido.com and you enter the code 99999, please indicate if you have any working experience on the topic of microplastics. Perhaps also a colleague of mine can share it on the link on the chat. Okay. Let's see.
Okay.
So it seems that most of you, as I see here, because I don't see exactly how many people, 2 participants have responded. Try to respond a bit more just to get an understanding. Okay, 3 people. Let's reach the critical mass of 10 people, and then we will move to the next slide. Don't be shy. It is just for us to understand a little bit better your background. Okay, I don't want to take much more time on this. Anyway, you will have the opportunity to respond to this question also while I'm moving to the next slides. But here I have another question for you. So the question is whether you are aware of actions taken in your country in relation to microplastics. And if so, to indicate whether these are research and monitoring, prevention, remediation and removal, education, awareness raising, and regulatory. I see that one person responded none of the above. It is true that microplastics has been relatively recently explicitly addressed by for example, the Regional Plan for Marine Litter Management in the Mediterranean, and now countries are accelerating their efforts in addressing the problem. But I see also that in some countries, there have been efforts either related to research, prevention, education, and regulatory. In fact, you can continue to vote on this question, but in fact, we asked some of these questions in a pre-webinar survey. And here is an overview of the results. So far, around 20 people have joined this survey. And one of the questions was which one of the below statements is correct, whether microplastics can be unintentionally formed, whether microplastics are deliberately manufactured, or whether these sentences are both correct. And we see that the majority of people responded that these sentences are correct. I will not provide the correct answers. I will do that throughout the course of my interventions. Then the second question was, which of the following products are considered to be a source of microplastic pollution? And we see that the majority of the poll participants indicated food packaging, clothes and cosmetics, and to a lesser extent, paints and tires. We will see what are the major sources of microplastics pollution. The third question was related to the which which of the following products can contain intentionally added microplastics? So most of you said cosmetics and toys, and then followed by paints and to a lesser extent bags and detergents. Then all of you responded that microplastics are a threat to human health. Microplastics in the marine environment pose a threat to human health. We will see about that. And when asked about which compartment, in which marine compartment microplastics are most commonly monitored, you indicated biota and sea surface, and to a lesser extent, seafloor sediment and beach sediment. And last but not least, the question that I just asked you, most of you indicated that the efforts, the actions in your country are related to research and monitoring and to education and awareness raising. And some of you indicated that there are no actions on the topic, while to a lesser extent, these actions focus on new regulation, education, awareness raising, and remediation and removal. And last but not least, here is specific responses to the kind of actions that are being implemented in your countries. I will not go into details. In fact, I will share with you this slide later on so you can have a look at what kind of actions are being implemented in the different countries like Montenegro, Egypt, Lebanon, Morocco, and so on and so forth. So this is just an introduction about the today's module. And now I will move on to the first presentation that will introduce the topic of marine plastic pollution and microplastic pollution and provide you with some terms and definition. So the topic of marine plastic pollution has been really making a buzz in the last, I dare say, decade, even though as Professor Skoulos highlighted, this is not a new topic, it's a rather long-standing topic. It is just that it has been receiving attention and momentum in the last decade or so. And here you can see an overview of the amount of plastics that are being produced every year worldwide. About 400 million tons of plastics are being produced. And you can see that the majority of plastics are being used in the packaging sector, followed, in fact, almost 1/3 of the plastics produced are being used for packaging, followed by the building and construction sector, textile sector, then being used in consumer and other products and transportation related products and electronic products, but also in industrial products. So obviously, one of the greatest sources of plastic pollution has to do with packaging. simply because packaging is the largest portion of plastics being produced. I'm sorry, but there is one microphone open. Can it be muted? I'm really sorry. Mr. Khadir Mustafa, can you please close your mute your microphone because we hear it. Okay, great. So, of course, plastics have gained such a widespread use because they have some key features that make them suitable for wide-ranging applications. And but the problem is that, of course, on the one side, the widespread use of plastics was anticipated, but the problems associated with plastic waste management were not. And it has been calculated that, for example, in 2015, out of the 6,300 million tons of plastic waste that was generated, only a small part, around 10%, was recycled, while the biggest fraction, 80%, has been accumulating in landfills and in the natural environment. And this, of course, makes clear how big the problem is. So now, when it comes to plastic and microplastics and what they are made of, first of all, a first sort of classification is the classification of plastics in thermoplastics and thermosets. The first can be repeatedly molded and deformed plastically when heated, while thermosets, once formed, they cannot be remolded by melting. And the most common thermoplastics that most of us are aware of and use in our daily lives are polyethylene terephthalate, polypropylene, low-density polyethylene, high-density polyethylene, expanded polystyrene and polystyrene, polyvinyl chloride, and so on and so forth. And then when it comes to thermosets, we have polyurethane, phenolic resins, epoxy resins, silicone, vinyl ester, and other acrylic resins. And on the right-hand side, you can actually see the different products that the different polymers are being used. For example, high-density polyethylene is being used for milk bottles, freezer bags, shampoo bottles, ice cream containers. And also, you can see from top to bottom with the different colors, you can see the easiness and or the difficulty with which the different polymers are being recycled. So high-density polyethylene and PET are being recycled more easily, and then low-density polyethylene and polypropylene less easily, and polystyrene and expanded polystyrene more difficult. Another major classification of plastics has to do with the source from which the raw material for synthesizing plastics comes from. So we can have bio-based plastics and petrol-based plastics. There is a lot of miscommunication of the term bio-based, making a lot of people believe that bio-based plastics are more environmentally friendly, but this is not the case. This just indicates the material from which plastics have been made. So they have been made from renewable resources, and these resources can be corn, potatoes, rice, soy, sugarcane, wheat, or vegetable oils, while the conventional plastics are being made from non-renewable petroleum-based resources. And both plastics made from both source resources, either renewable or non-renewable, when it comes to their chemical composition, they are identical. So another major attribute of plastics has to do with degradation processes. So first of all plastics degrade eventually. So one major difference between the different plastics and plastic polymers is how much time that takes. It could take a few years or a few decades or a few hundreds years. So and of course, depending on the factors that induce the degradation, we talk about chemical, physical, or biological reactions. And here you can see the different agents that can induce this kind of degradation. This can be heat, and we talk about thermal degradation. It can be light, sunlight, and we talk about photodegradation. It can be oxygen, so we talk about oxidative degradation. It can be water, so we talk about hydrolytic. It can be some stress, mechanical stress, so we talk about mechanical, and then it can be the presence of microorganisms, so we talk about biodegradation. And this kind of degradation undergoes two phases. In the first phase, we have the disintegration of the plastic products, which break into plastic fragments. And then in the phase 2, we have the mineralization, and depending on whether the digestion is aerobic or anaerobic, we have the production of water, biomass, energy, and either carbon dioxide or methane. So now that we got that part straight, when it comes to plastic and how it ends up in the marine environment, as we said, a lot of the plastic products being used are sadly not being recycled, and one way or the other they find their way to the coastal and marine environment. And in this figure you can see on the one hand the different human-induced activities that act as releases, entry points of litter in the marine and coastal environment, or some pathways, such as the case of rivers, wastewater outfalls. And also all of this litter can travel long distances due to the winds or the movement of waves and to other meteorological phenomena. So the problem of plastic pollution is growing, and is not just a marine pollution issue, but plastics are present in the air, at land, and of course in biota. And with this, pollution has different entry points, and it has different various size fractions, and of course wide-ranging effects. And these effects, at least for the marine environment, and you will hear a whole lot more about that from Professor Cristina Fossi, these effects include entanglement, they include ingestion, they might include the release of toxics that are either have been added, are chemical additives to the plastics and leach once they have been ingested by marine organisms, or either are accumulated on the plastic particles and are released once they are ingested. Plastics can also facilitate the movement of invasive alien species, because these species might attach themselves on plastics and travel long distances and enter environments that they don't belong to. They can cause damages to benthic habitats and communities through the abrasion of coral reefs. And on the right-hand side, you can see a photograph that I have taken from the seafloor of Capo Milazzo. This is a protected area in Italy. And of course, they can cause other damages to benthic habitats due to reduced oxygenation and smothering of benthic communities. Now, when it comes to human health impacts, and I will come back to that later on, and regarding also your responses to the question that was asked in the pre-webinar survey, it is true that humans are exposed to a large variety of plastics and microplastics and nanoplastics through inhalation, ingestion, and direct skin contact all along the plastic life cycle. And in fact, it has been calculated that the exposure of humans through inhalation to microplastics is the greater kind of exposure, and to a lesser extent by consuming marine organisms that have ingested microplastics. But there are no toxicological data on the consumption of microplastics by humans that could potentially produce a comprehensive food risk assessment, food risk safety assessment. So basically, at this given moment in time, we don't know whether microplastics and nanoplastics induce adverse effects on humans. But we suspect that this might be the case. Plastics are not just a marine pollution issue, but they are also a climate change issue, as plastic contributes to greenhouse gas emissions at every stage of its life cycle. And there has been a comprehensive report on the topic and the hidden costs of a plastic planet. And it has been calculated that the greenhouse gas emissions for plastic could reach by 2050 at 10 to 13% of the entire remaining carbon budget. So we understand that we need to reduce the amount of plastics being produced, which means that we need to make the use of plastics more effective, more smart, more wise, obviously because we cannot afford living without them at this given moment in time. Professor Skoulos went through a little bit about the key legislative frameworks framing our work related to microplastics and plastics. Here I have listed the most, let's say, relevant and the most, more strong and strict frameworks, not loose or soft. And these are the Marine Strategy Framework Directive and Descriptor 10, the plastic strategy that entails a lot of measures about plastic production and a lot of targets related to their use, and the most pioneering piece of legislation at the international level, which is the Single-Use Plastics Directive that prohibits the use of certain single-use plastic items. And more recently, we have, of course, the Green Deal that brings these different pieces of legislation together, but also the ocean missions and the Lighthouse for the Mediterranean that entails concrete actions for addressing plastic and microplastics in the Mediterranean. And at the Barcelona Convention level, of course, Christos will go into more details. There is the ecosystem approach and the ecological objective 10 that frames our actions for addressing the problem, and the upgraded regional plan for marine litter management in the Mediterranean. So before I move to my next slide, I would like to kindly ask you to respond to another Slido question. So please go to Slido and select one of these three responses when it comes to the definition of microplastics. So microplastics, how are they defined? As items smaller than 5 millimeters, smaller than 5 millimeters and bigger than 300 micrometers, or smaller than 5 millimeters and bigger than 1 micrometer? Okay. I see that most of you responded smaller than 5 millimeters and bigger than 300 micrometers. Okay. In fact, this was kind of a trap question. And you can continue answering because simply there is not yet a consensus on the definition of microplastics, neither at international nor at the European regional sea level, neither at Mediterranean level. And in fact, there is a very interesting article that I have shared with you, the link here, that entitled Microplastics, Finding a Consensus on the Definition. And it kind of presents an overview of the entire story of how the discussions on microplastics were initiated, and how different scientific teams have been defining microplastics in different ways. So the story started, of course, with Richard Thompson. I think that most of you are aware of him. He actually has also received an award from the Queen of England for his outstanding work on microplastics, where initially he spoke in 2004 about microplastics and he referred to them as the accumulation of microscopic pieces of plastic in marine sediments and in the water column of European waters. And a few years later, Arthur and al. Proposed an upper size limit to the initial term. And this upper limit is 5 millimeters. So most of you guessed correct. This is the upper limit. But apart from the upper limit, there is a lot of discussion about the lower limit, about further classification of microplastics into primary and to secondary microplastics. And in fact, the joint group of experts on the scientific aspects of marine environmental protection, GESAMP, defines plastic particles smaller than 5 millimeters in diameter, which include particles in the nano size range of 1 nanometer. So this was a small sort of storyline of the discussions on microplastics. So still today, there is no clear consensus, and this causes a lot of issues when it comes to monitoring and investigating microplastics. And basically within the webinar and within all our documents, we are going to deploy the definition that has been given by FRIES and NAS in 2019 through a large-scale European project trying to define the precise definition for microplastics. So we will define them as any synthetic solid particle or polymeric matrix with a regular or irregular shape and with size ranging from 1 micrometer to 5 millimeters and of either primary or secondary manufacturing origin. And on the right-hand side, you can see some size references of nanoplastics and microplastics, and also the reference to macroplastics, which is the common plastics and size class that we monitor, for example, on beaches. Then we have mesoplastics, which commonly are defined as items smaller than 2.5 centimeters and until 0.5 centimeters. And there is agreement that this requires a dedicated monitoring approach. And then we have microplastics, which is the focus of our today's module, and nanoplastics that, of course, requires more sophisticated approaches for research and monitoring. So apart from this definition, microplastics are being classified also by shape and color. And even though both of these classifications have been debated, simply because there is a lot of subjectivity introduced when classifying microplastics. So commonly microplastics are being classified according to their shape in fragments, lines or fibers, pellets, films, and foams. And this classification is important because it's associated with their sources. So for example, fragments are commonly coming from bottles and in general items that are being made by hard, sturdy plastics. Line and fibers are either originating from fishing related activities, fishing nets, for example, and clothing or textiles. Pellets, these are basically either virgin resin pellets that are being used for synthesizing, for actually producing different types of plastic items, or are being added to cosmetics like facial cleansers. And then we have films that most probably originate from plastic bags or packaging, food packaging like food wrappers, or plastic sheeting, which has been used to package products, for example, or cargo. And then we have foam that is being used in foam floats, in styrofoam cushioning. So just a small overview of the potential sources. Obviously, there are other sources that could be linked with this type of microplastics shape. And then another, as I said, classification has to do with colors. And usually the naked eye is being used to define the color, but in fact, a lot of discussions are being made to use equipment to do that in order to eliminate the subjectivity of the naked eye in terms of defining the color. And the reason for doing that is because certain marine organisms have a behavioral preference for certain colors of microplastics, and therefore the color of microplastics has to do with the potential risk of microplastics in different marine organisms. And we discussed a lot about the definition and the upper and lower limit, but of course there are other additional size classes of microplastics, and because size is important, and different sizes of plastic particles need different types of equipment and analytical techniques in the laboratory in order to classify and identify and classify the plastic microparticles, but also the size has to do with the potential impact on ocean life and on human activities such as fisheries. And Professor Cristina Fossi will provide you with some examples when it comes to that. So first of all, one microphone is open and is creating a little bit of noise. If it's possible to shut it down. Okay. And here is another question for you. And the question is whether you think, based on also on what you heard, that all microplastics can be filtered out of wastewater in wastewater treatment plants. Okay. It is true that this statement is false. And it's clear, considering that the small size of microplastics that we have been discussing. And on this slide, on the right-hand side, you can see the different sources of microplastics in the marine environment. Obviously, wastewater treatment plants are a pathway to that end. And in fact, I forgot to share with you a very important study that has been conducted by a Greek researcher, Chrysi Karapanagiotis, on the topic, showing how different the amounts of microplastics being released by wastewater treatment plants. So microplastics, in addition to the previous classifications that I described, are classified also in primary microplastics and secondary. Primary microplastics are those manufactured for the purpose of being added to other products, okay? And for example, this is the case of plastic pellets. This is the case of microbeads added to cosmetics or added to detergents. And then secondary microplastics are those created by fragmentation of and degradation of macroplastics. And this is the example, for example, of abandoned fishing gear. This can be the example of microplastics lying on the coastline, shipping related items that at the end of the day fragment into smaller pieces, but also synthetic clothing that can release, due to washing, it can release microfibers into the waterways and in wastewater systems, and but also the abrasion of road markings and the abrasion of tires. So, because again, there is a lot of discussion about this kind of classification to primary and secondary, and there are some practitioners that consider, for example, the release of microplastics from clothing as a primary source of microplastics. So in order for all of us to speak the same language, we are going to deploy the definitions provided by the Regional Plan for Marine Litter Management in the Mediterranean. And so primary microplastics will be tiny particles designed for direct commercial use, as I mentioned, for cosmetics, detergents, and paint components, or for indirect use, such as pre-production pellets. And then the secondary microplastics will refer to the result of the breakdown of larger plastic items into numerous tiny fragments. And for example, microplastics in wastewater treatment plants from washing clothes will be considered as secondary microplastics. So now I have another question for you. And the question is, which type of microplastics you think cause a bigger environmental problem? Primary microplastics or secondary ones? I do think that this is a tricky question, but I think that it provides good food for thought, because obviously someone can argue and say it depends on the chemical composition of the microplastics, it depends on the size class, on the color, and so on and so forth. But here, if we consider the amounts of microplastics being produced by primary and secondary sources, the largest fraction of microplastics is being secondary microplastics. Actually, it has been sort of calculated that 90% of the microplastics in the coastal and marine environment comes from secondary microplastics, so from the fragmentation of macroplastics, and primary microplastics are just at 10%. This means that, for example, actions to address macroplastics at large, they address also the biggest part of microplastics, that is secondary microplastics. And another point that I would like to highlight is the contribution of rivers in terms of microplastics. And in fact, there has been a very interesting study assessing the relative importance of the export of microplastic from river catchments in Europe to sea. And as you can see on the graph, the Mediterranean has been the sort of a winner, in the sense that the largest amount of microplastics is being released in the Mediterranean Sea due to rivers like Po and others. And when it comes to the composition, this study was very important because it shed light on the types of sources. And as you can see, the greatest source of microplastics has been the wear of car tires. And that is why at the European level, a lot of emphasis is being placed on manufacturing tires that will significantly prevent the release of tiny particles that, due to runoffs, rainwater runoffs, end up in the coastal and marine environment. And then the second most important source has been, of course, the laundering of clothing through large amounts of microplastics released through wastewater treatment plants. So just to wrap up all these terms and definitions that I provided, here in this graph, you can see that we can have synthetic polymers can originate from fossil fuel. They can also originate from bio-based sources. Then these synthetic polymers, irrespectively of whether they're bio-based or petro-based, they have the same chemical composition, with the exception of biopolymers. And then either they can be thermoplastics or thermosets, and this has to do also with their capacity to be molded and to be recycled. And then through the different degradation processes, from macroplastics, they fragment into microplastics, or we can synthesize microplastics in order to add them to specific dedicated applications. And so this is just short introduction on the topic. As I said, because I cannot see at this very moment the chat, please post any questions you have on the topic, And then once we conclude with interventions, we are gonna run through your questions and try to respond to them one by one. And now I will go through my second presentation. And just a second, because here we are, which will provide you with a quick overview of, on the one side, the amounts, sources, and effects of microplastics in the Mediterranean. But also I will make an effort to give you a quick overview of the research gaps and knowledge needs, because unfortunately François Calcagny, who was one of our trainers, couldn't be here with us today simply because he is in a different time zone in Tahiti. So unfortunately we could not have him with us. It is widely acknowledged that the Mediterranean Sea is one of the most affected areas by marine litter, marine plastics and marine microplastics worldwide. Here you can see just a few photos that I have taken throughout my missions in different parts of the Mediterranean of the magnitude of the problem. And as we already discussed, there are different sources of plastics and microplastics. And in fact, there has been a study that calculated that the total annual plastic input in the Mediterranean basin is equal to 100,000 tons. And roughly 50% originates from various land-based sources, 30% from rivers, and 20% from sea-based sources. And this, of course, is a general estimate when treating aggregated results. While when we go into specific sites, this kind of percentages can change depending on the different characteristics of the sampling areas. So, and actually it is not that easy to assess the relative importance of the different sources, simply because it's not that easy to identify the kind of activity that generated a certain litter item, simply because it is being used and in sea-based and in land-based activities, but also it could end up through important pathway as rivers. But of course, in the Mediterranean, tourism and recreational activities are very important. And then a lot of discussion about the origin and the transboundary effect. In fact, this is a very, very difficult thing to assess. And someone might argue and say, I don't know, that maybe through the barcodes of products, we can say, for example, whether a litter item originated from a certain country. But this is also very debatable in the sense that we live in an era of free commerce, and products with barcodes, let's say, from one country can be found in another country, but can have been released by that country. So it's not so easy to use barcodes. It's not so easy to use specific items and say that these traveled through the marine environment and reached a certain country. And in fact, different modeling exercises indicate that the majority of litter items in one area are generated sort of in situ in that area. About the marine litter impacts, just to highlight that since the Mediterranean is a haven for rare and endangered species, a lot of the species are being threatened by marine litter. Actually, at the worldwide level, 15% of the species affected by entanglement and ingestion are included in the red list of threatened species, and an increase of affected species has been recorded, while a lot of species have been recorded to ingest litter. But now, when it comes to the effects of this ingestion, first of all, uncertainties still remain to the extent regarding the extent of the harm caused. And in fact, most of the studies are documenting the ingestion and not the effects. And this is the important part that Christina Fossi will address through her intervention, how we can measure, how we can assess the actual effect on the health of the organism. Also, at the moment, there is no evidence to support or refute potential biomagnification of particles or associated chemicals. As I already mentioned, basic toxicological data on the consumption of microplastics and nanoplastics by humans for food risk safety assessment are lacking. And also, we don't have a solid assessment of the full economic cost of marine litter, simply because it's very difficult to assess the cost incurred by the inhibition of the proper functioning of the ecosystems. So an attempt has been made a few years ago through the Fish Year project, and here you can get an estimate of the figures of the costs that have been calculated. Obviously, these costs may have increased because this study was conducted, I think, 6 years ago. But it documents that, yes, there are costs incurred by the threat of marine litter. And I will not stay that much on this slide, but I just wanted to highlight that obviously we talk about plastic pollution and microplastic pollution because the majority of products being used are plastics, and therefore the majority of waste discarded is made of plastics. And at the end of the day, this kind of plastic waste is being released to the coast and seas and make up 70 to 90% of all litter items. And in the previous regional training, we had explicitly addressed the topic of single-use plastics, which in some cases, they reach up to 50 or 60% of the total litter items found in the coastal and marine environment. And fishing and aquaculture, a source that was overlooked in the Mediterranean, can in some cases reach up to almost 40% of the total items recorded. So it is an important source. And when it comes to microplastics, at this given moment in time, we don't have reliable estimates of how much is entering the marine environment on an annual basis. But what we do know is that microplastics greatly outnumber large plastic items. And even if we would stop, let's say today, the release of plastic waste into the oceans, still plastics would continue, the plastics in the coastal and marine environment would continue to degrade, would continue to fragment, and would continue to increase the amount of microplastics and nanoplastics with whatever effects this might have. Now, when it comes to studies, microlitter studies in the Mediterranean, in fact, our beloved sea is a pioneer when it comes to that, is one of the most studied regions in the world. When it comes to microplastics contamination, there is a large number of scientific publications released on the topic. And these studies focus on monitoring beach sediments. And on the left-hand side, you can actually see Eleni sampling. I think it was in Croatia, in Split, the coast. Then there are studies dealing with the sea surface, the seafloor sediments, and biota. And on the right-hand side, you can see Christina taking biopsies from citations. So when it comes to microlitter studies in the Mediterranean beach sediments, so basically on the beach, Eleni will explain a whole lot more about this approach and the sampling protocol and the analytical protocol applied in the laboratory. Here you can see the different areas that have been studied, and you can see the references to that studies. But it is obvious here that different size classes of microplastics are being sampled, different parts of the beach are being sampled, different depths, samples, different, layers with different depths of the beach are being extracted. and then the processing of these samples in order to arrive to the final identification, characterization of the microplastics differ. And this is not only the case for beach sediments, but this is the case also for all microplastics studies and monitoring approaches. In the answer, which kind of microplastic sampling is more widely, let's say, implemented in the Mediterranean, the correct answer was the sea surface. Here you can actually see sampling of the sea surface through the Plastic Busters initiative. I think we were in Corsica, if I remember correctly. And here you can see an overview of the different studies that have been conducted in the last 10 years, quite a lot of studies. And you can see the different gear used, manta nets or Nepstonic nets. In fact, the entire approach of sampling floating litter originated from sampling zooplankton. You can see the different mesh sizes of the net that is being used to sample the litter. So you can see that some use a 330 micrometers net, others a 200 micrometer net, others a 500 micrometer net. And this, of course, creates an issue when it comes to comparing the results obtained by this kind of surveys. And here I just wanted to share with you some indicative densities. So you can see here, first of all, that in some cases results are being expressed in items per square kilometer. In some other cases, they're being expressed in items per square meter. Of course, this can be easily overcome by multiplying, but you will notice that there are differences in the magnitude of the densities recorded. And I will come back to that, why that is happening and why it's quite tricky to compare these different densities. But in some areas, very high densities have been recorded. And this is why oftentimes we have been hearing the phrase, the Mediterranean plastic soup. But it's just a buzz phrase in order to attract attention. So about floating microplastics, I just wanted here to highlight that the most commonly found plastic types are polyethylene, polypropylene, and polyamides, simply because of their buoyancy. And one of the less studied marine matrices have been seafloor sediments. Simply because this kind of sampling is more sophisticated and it requires more sophisticated sampling gear. Some very few studies have dealt with seafloor sediments from high depths. I think one of the studies that has been conducted in the largest depth has sampled seafloor sediment from 5,000 meters. And most commonly, microliter studies focus on coastal and shallow waters from 8 to 10 meters or up to 20 or 30 meters. And I will not provide you with any figures about microliter sampling in biota, because Christina is going to provide you with a very comprehensive picture on that. I just wanted to give you this figure that illustrates the percentage, let's say, of species being used for studying marine litter ingestion in the Mediterranean Sea. And as you can see, that the majority of species that are being used in these studies are teleostotes, followed by elasmobranchs and seabirds, and to a lesser extent, arthropoda have been used, or mollusks, or marine mammals. And Christina will come back to that figure again. In respect to the knowledge gaps and research needs, we can in fact kind of cluster them in two major categories. So data gaps and research needs related to analytical methods. So despite the fact that we have a large number of studies and scientific papers on the topic of microlitter in the Mediterranean Sea, there is still a lack in knowledge that is required to fully understand the distribution, concentration, and chemical composition of these microplastics and the effects that they can induce to the health of the Mediterranean Sea and its species. Then the different studies are not easy to compare because of the heterogeneity of the Mediterranean Sea environment. So it is not just a methodological issue related to sampling, microplastic extraction, analysis, the size classes considered, or the concentration units, but it's also because the different areas of the Mediterranean are characterized by different hydrodynamic features, different circulation patterns, the impact of seasonality is different. So then the densities are wide-ranging, and this makes things very difficult to compare. But also I would like to highlight one other important need and the gap, and this is related to the lack of quality assurance and quality control instruments. And to my knowledge, there are no organizations to date that offer proficiency training or testing in microplastics samples processing. And I think that Christina and Eleni maybe can say a few words about a huge intercalibration exercise that was conducted within the framework of Plastic Busters in order to ensure that all the laboratories involved in this large-scale initiative were measuring correctly, properly, accurately the different microliter samples collected. And this is actually my last slide. And here I just would like to draw your attention on a very comprehensive 200-page report that was conducted by the Science Advice for Policy by European Academies, the so-called CHAPEA. And this is in fact one huge blueprint or reference point when it comes to our knowledge on microplastics in nature and society. And basically this report on the one side highlights that we do know a lot about microplastics, but still much more knowledge is being needed because evidence remains uncertain due to the complex nature of microplastics, due to the differences in size, shape, chemical additives, concentrations, measuring techniques, fates, mixture effects, human factors. Then we do know a lot about the concentrations in fresh waters and ocean surface, but to a lesser extent, we know about concentrations and implications below water, which is being addressed by SDG 14. Then, when it comes to human health risks, we have no evidence of widespread risk to human health from microparticles and nanoparticles. And when it comes to, sorry, can you mute your microphone, please? When it comes to microplastics in marine organisms, a lot of these go in now.
Disactivate your microphone, please.
I'm sorry, can you please mute your microphone? Okay, thank you. So, yeah, in fact, as with many chemicals, the poison makes the dose, or is in the dose, sorry. And in fact, the thing is that a lot of studies that are highlighting the impact of microplastics on marine species are actually, and are being conducted in the laboratory, are using very high densities of microplastics that are far away from real environment conditions. And therefore, these studies may result that microplastics pose a great risk for marine organisms. But then again, we need to look better into real world types of microplastics when it comes to their shape and size in order to document properly and assess properly their adverse effects in the marine environment. And Christina will provide you with some examples and some evidence that has been coming up from the Plastic Busters thorough study that was conducted in marine protected areas and endangered species. So with that, I would like to close my, let's say, contribution to this module. And I would like to kindly invite Christina to share with us her knowledge and her expertise on the topic of, on the one side, microplastics effects on biota, and on the other side, on cutting-edge monitoring approaches to assess these effects. So thank you all for your attention. And Christina, the floor is yours.
Thank you very much, Tommy, and thank you very much to Professor Skoulous and to you to involve me in this very, very interesting webinar. I would like just to say two things very personally before to start my presentation. The first one is obviously is great honor for me to be here because we know that in the last decades we have worked a lot of together, and we strongly believe that the collaboration of scientists and researchers between the Mediterranean Sea will be really the key action to do in order to monitor, but particularly to mitigate the impact of marine litter on the Mediterranean area. And so that is really our goal in the future. The second aspect, after the very nice and comprised Tommy presentation, maybe you have a lot of expectation on my presentation, and definitely I don't think I can answer all the point that Tommy focused, because as we know, the point is extremely difficult, but I can try to give my contribution on this. So I share my presentation, if I found it, sorry. Just a moment, sorry. You see my screen?
Yes, we can see
Yes,
your
we
screen.
do.
Perfect. Thank you very much. So as I've already mentioned from Tommy, probably one of the most challenging and difficult aspects to try to understand is to define the impact of marine litter on biodiversity, and particularly on the Mediterranean Sea, that, as we know, is one of the 25 hotspots on biodiversity around the world, but in the same time is one of the most exposed areas worldwide of marine litter. So I think the main goal of my double presentation will be to touch two main concepts as a request from Tommy. The first one is try to define the potential role of microplastic to transfer pollutants and contaminants in the environment, and particularly what can be the most critical chemicals in which we have to focus the attention. And I think that will be the most boring part of my lectures. In the second one, as previously mentioned from Tommy, I would like just to give an overview of the main methodological approach that we have developed in the last decade in order to try to define the potential impact of marine litter on biodiversity, not in one species, but in the most wide range of bio indicator species that are present in our Mediterranean environment. I have some very small introductory section that I think I can skip very rapidly because the presentation of Tommy was really very nice, very fantastic, even for an expert. I don't know if I'm really an expert or not. I enjoy very much how Tommy have touched all the different aspects. And I would just to focus the attention that microplastic definitely is one of the emerging topic that the scientific community, the media, and even fortunately the governance have touched the attention on global scale, in particular on the Mediterranean Sea. On the other hand, I said that also the topic of marine litter becoming the last decades very fashion trend topics. If you switch on the TV, you can listen the popes, that is a fantastic person, and even stars of Hollywood that talking about marine litter. And I definitely think that is very important what stress from Tommy, that is very, very clear to have this merge from science, policy, and awareness rising in order to give the most solid scientific basis to the information. And what really it's our job in the last decades. I would like just to show this video that I like very much in order to see how really the problem of marine litter and microplastic can be extremely devastating the Mediterranean biodiversity. Here you see the largest marine organism present in our fantastic Mediterranean Sea. It's a very nice picture because you can see a mother and a calf that are swimming in the Pelago Sanctuary. As you know, is one of the protected area for marine mammals in the Med. But if you're looking in detail in this video, you can see that the water is completely full of plastic items. I know that are plastic items, are not microplastic. So that means that obviously that problem is a massive problem on the Mediterranean Sea, and this massive problem generates also, as we mentioned before, a lot of attention in terms of publication, particularly in the last 5-6 years. And as mentioned from Tommy, we are approaching on this topic very, very early when in the Med, when we published in the 2012, the first paper worldwide on the impact of microplastic on baleen whale. And it is really the beginning of our story in this very attractive and complex phenomena. So I will try just to give some data concerning this and how really the presence of microplastic and marine litter can generate a potential impact on Mediterranean biodiversity, and what, on our point of view, can be the most successful methodological approach to be applied in order to try to give some answer, that we have not give all the answer, but some answer. And as already mentioned from Tommy, we have the topic of microplastic is focusing more on different category of microplastic. And it's very important to define the potential impact of primary and secondary microplastic. And I like very much the question that you posed, Tommy, because I think it's very, very important. And even Tommy have already mentioned one historical data in which the Mediterranean Sea was defined worldwide one of the most exposed area on the impact of marine litter, because we know that the concentration of macro and macroplastic on the marine surface are on the same level of the five gyre. So we are in the middle of one of the most important areas in terms of biodiversity, but this great biodiversity interact with this dramatic impact of marine litter. And so that coming from the first point that I need to clarify with you, that is not easy, but we can try to summarize in some main concept. So the point of plastic and microplastic as a vector of chemical pollution. When we discuss about the idea of microplastic, we know that the story in terms of potential effect on marine organisms is extremely complex, because we normally define that microplastic can impact marine organisms ranging from invertebrate to the charismatic marine mammals such as whale in 4 different ways in terms of ingestion. And the different ways are reported in a very synthetic way in this slide. So the first one, microplastic can generate a negative effect on marine organisms related to transport of persistent bioaccumulating toxic, so what we define PBT, substances that can be attached from plastic in the marine environment, and we'll describe this concept. But the most probably critical negative effect in terms of chemicals is related to plastic additive, because as we know, plastic is composed from polymer, but this polymer, in order to be very effective for the construction of objects, need to be a support from additives. And most of these additives, as we'll see later on, can produce negative effect on marine life. So the two main toxicological effects of chemicals in terms of plastic and microplastic in terms of transports of chemicals are the contaminants that can be leaching, absorbed, from the microplastic itself. And we will go in detail on this concept. And the second probably most important aspect is the leaching of additive. But even when we discuss about the ingestion of microplastic from marine organisms, we have to focus the attention on 2 other extremely important points: the physical harm and the potential transfer of the virus and bacteria. So the physical harm is a very important negative effect that can produce microplastic in the ingestion of marine organisms, and can really one of the bases of the negative effect in terms of biological endpoint that we see in the second lesson. And one of the less explored aspects is even the idea that microplastic can be transported by a virus and bacteria. We know the concept of biosphere, and all this concept is needed to stress very much, because if a marine organism such as a plankton, whale, or an invertebrate ingest microplastic, the ingestion of microplastic can generate in the marine organism a multiple stress. So there is not a single stress, but a multiple stress. So this is why it's so complex to investigate the potential negative effect produced from the ingestion of microplastic in marine organisms. Here I report, and I have already sent you some very nice picture, and there is some reference paper in which we define how really the microplastic, when are released in the marine environment as primary or secondary microplastic, can realize a kind of chemical interaction with pollutants that are present in the environment, such as POPs, such as a kind of different hydrophilic compound that are reported here, but even pharmaceutical or heavy metal. So the microplastic can represent for the physical-chemical characteristic a kind of attractive material for all this compound, and that can really represent a carrier of chemicals in the ingestion of marine organisms. And that is a very important concept. But even when you're talking about the potential role of microplastic as carrier of chemicals, as I have already mentioned before, we have to focus the attention that we need to clarify the 2 different characteristics of chemicals. So we have all these POPs or PBT that can be absorbed from the marine environment and can be concentrated on the surface of the microplastic, but even we have to consider another extremely important aspect, that there are the microplastic as a carrier of additives. So the two aspects can really take in consideration and need to explore in terms of toxicological effect. Again, coming to this paper, we see how the ingestion of microplastic, both in terms of absorbed contaminant and in terms of additive present itself in the plastic, when it's arrived in the marine organism with the different route, that can generate a series of toxicological effects. So chemicals and toxicological effect need to be explored in detail in consideration of the potential negative effect on biodiversity. As mentioned from Tommy, obviously the ingestion is not the only negative effect that marine litter can produce in biota. We have a lot of wide range of effects, such as the habitat destruction and degradation, the entanglement, and is typical for the large marine organisms such as cetaceans, and itself the spread and transport of invasive species. All these factors need to be taken in consideration when we define the impact of marine litter on biodiversity. But on this specific webinar, we have to focus the attention on a more specific field that are related to the ingestion of microplastic to marine organisms and the transport of chemicals binding to these. So when we talking about the transport of chemicals of microplastic, we have to thinking that is a very complex picture. So we have to think that we have to enlarge the idea that microplastic can transport a complex mixture of chemicals, and this mixture of chemicals can be different in the different marine environment. So the contaminants that can be at very high level in the med, such as also all xenobiotic compound, but even the heavy metal can be different from the chemicals that can be transferred in another environment. And also it's very important to explore the environmental fate of these chemicals from plastic and the transport from ocean. And that is our main goal, our group of research, and in a fantastic consortium, Plastic Buster and PAs, to try to define the multiple stress on the impact of wildlife. And we will touch this concept later on. So coming, I think, in the most boring part. So when we discuss about chemicals, which kind of category of chemicals can be related to toxicological effect to the ingestion of microplastic? As we have defined in the first part, obviously microplastic can transport a kind of cocktail of chemicals. So it's very complex picture. And I think we have to divide in two main categories. The first category is represent from ingredient of the plastic material that we define additives. And the second one are the contaminants that normally are present in the marine environment and that can be absorbed from plastic as the persistent bioaccumulative contaminants. And so I will rapidly describe some of these class of chemicals, and later on we come to define the effect. So we know that the PBT compound are present worldwide in the marine environment, and unfortunately the Mediterranean Sea is one of the most exposed environment in the world from these kind of chemicals, and we know this is exactly for the same reason of marine litter, because we're living in a closed environment with a very small exchange of water with the Atlantic Ocean. It's a very industrialized area, very anthropized. And so a lot of these xenobiotic can be present in very massive concentration in the marine environment. And this produce widespread global contaminant chemical distribution and the binding of this chemical with the oh my God. So when we're talking about bioaccumulative and toxic substances that normally we define as PBTs, we define a specific class of chemicals. The most famous one, the most studied one, is the PCBs, so the polychlorinated biphenyls that we know are compound or heavily used until now from industry, but not only, also in agriculture for different purposes. And they are compounds that have a very high lipophilic affinity and a very high long life. That is the main problem of this. And they tend to bioaccumulate and biomanify in the marine food chain. On the other hand, there are other two classes of chemicals, such as the PAHs that are not xenobiotic compound because they're coming from the oil production. They can even be represented in this class of category. They are still lipophilic compound and they can bind into microplastic itself. The characteristic of this class of chemicals are low water soluble, and for this chemical physical reason, they tend to sorb of the this kind of material. But this concept generated a lot of several years ago a new strategy on at global level that was called the pellet watch, in which the measure of the composition of and the concentration of POPs in pellets on the beaches around the world can also use as a kind of model to define the, in one hand, how microplastic can be carrier of this kind of chemicals, but also in order to mapping the concentration of POP around the world. So definitely a lot of attention need to be put on these chemicals. But on the other hand, we need to understand that this kind of chemicals can produce several toxicological effects, and one of the most important one are represented for the endocrine disruptor potency of these chemicals. When we're talking about the other story of additives, until a few years ago was less explored because it's not very easy in terms to chemical detection, but we know that several different types of plastic manufacture have used to produce different products, but in order to have the real structure of some plastic, and particularly as maintain the most plastic, can say, characteristic of the polymers, the industry tend to add to the polymer itself several additives. Some of these are the flame retardant, some are the stabilizers, some are pigment, some other are used in order to achieve the flexibility or even the color of the product. The main problem to adding these chemicals to plastic is that they can be released during the production, but they can also be released in a very high level when can be ingested from marine organisms. And here I have report some of the most important category of plastic additive in which we are focusing the attention on the last. in the last years. One of the most important plastic additive that can be defined for the great toxicological potential that they have in the marine organism, they are the phthalate. Phthalate are heavily used in the production of plastic, and they are added to the product mainly to make them more pliable. So for example, PVC contain from 10 to 60% of these molecules. The main problem are that this class of chemical tend to leach into the environment during the manufacturing and also using the disposal. But as ecotoxicologist, I would like to underline that release phthalate in the marine environment can really generate one of probably the most critical toxicological consequence for the marine life, that is the endocrine disruptor effect. I don't know if you are not familiar with this concept, but an endocrine disrupting compound are a compound that have some chemical physical characteristics similar to the natural hormones present in the wildlife, and they can generate negative effect that alterate the endocrine system of the organism, and in particular of the reproductive activity of the organism itself. So a lot of attention was paid, especially in the last 2 or 3 decades, on the role of endocrine disrupting chemicals in terms of generate toxicological effect on, in general, the marine wildlife. So the main concept is that some of these plastic additive, in particular phthalate, and another class of plastic additive, such as the bisphenol, are compounds that are characterized from these endocrine disruptors.
Сади изошел. Нема да.
Could you mute the microphone, please? And the bisphenol A in particular, it's a very long story and can talk a lot for this point. So we need that globally, we still have a very massive production. I have found here 3 million tons produced annually of this compound. And so that is really one of the main point in which a lot of scientists have focused their attention in the past, but even now. So phthalate, bisphenols, both of them have a very dramatic endocrine disruptor effect on the marine organism. Finally, one of the other very important class of chemicals that are used as plastic additive and from the industry is the flame retardant. Flame retardant, as say the name, is reduce the flammability and they prevent the spread of fire, and they are component of most of the plastic material. And the last one, which I would like to focus the attention, are the perfluorinated chemicals, PFAS, that are listed under the Stockholm Convention since 2009, but even are widely used, and even this compound can be present on plastic. So at the end, the story is difficult and simple in the same time, because if marine organisms, as we saw, can ingest microplastic for different routes, they can ingest POPs, but they can also ingest plastic additive that can really dramatically can impact the potential of the fitness of the organism exposed to this class of chemicals. And in order to finalize briefly this first part of my lecture, I would like just to give some example of case study that we have realized on the plastic additive. part of the study are quite old, is from at least 12, 13 years ago, in which for the first time we propose phthalate as one of the most important chemicals that we have to following in terms to define the ingestion of microplastic to marine organisms, but even in particular in the Plastic Busters MPA project, we have developed new methodology in which we analyze these chemicals in several marine organisms with 11 different phthalates. But just to give you some idea how really can be important to define the presence of plastic additive on marine organisms, I would like just to take your last 5 minutes to discuss how microplastic can affect the marine biodiversity, and particularly the filter feeding megafauna, because obviously the organisms such as whales, such as basket shark or whale shark that used to filtrate a massive amount of water can really strongly expose to the ingestion of marine litter. And the 3 main case studies that I would like to briefly to show you are the first story of the detection of the impact of plastic additive on whale, and that is this pioneering paper that we published in 2012, in which for the first time we defined the presence of microplastic in the Pelagos sanctuary in the Mediterranean Sea, that is the marine protected area, SPAMI, in which the whales are feeding and reproductive. But in this study, the most important point that was which defined for the first time in stranded fin whales the presence of a very high concentration of this plastic additive, in particular phthalate. So that was one of the first I can say idea in which really these plastic additive can be used as a tracers of ingestion of marine litter, and particularly of microplastic on the marine biodiversity. The second example of phthalate as a plastic tracers was generated from another very charismatic species that we have in the Mediterranean Sea, that is the basket shark, that you probably know is the second largest fish that we have in the Mediterranean Sea, and have this very peculiar feeding behavior using to filter water on the sea surface. So it's a kind of giant sampling sentinel organism. And in this organism, we have detected a very huge concentration, again, of this plastic additive. But probably one of the most charismatic organisms that we have studied, not in the Med, but in the Pacific Ocean, that is really a potential indicator of ingestion of microplastic worldwide, is the whale shark. And I like very much this picture because it really reflects how the behavior, feeding behavior of these animals is very similar to the technical approach that we apply on the oceanographic cruise to collect and analyze microplastic. So here we compare the mouth of the animals with the mouth of the manta trolls. And if you consider that these animals are normally feeding for 8 hours a day in the sea surface, you can understand how this species can be really dramatically exposed to the ingestion of microplastic. And again, this ingestion of microplastic is related to leaching of chemicals and by accumulation of chemicals in the tissues. And here in the study, we focus the attention not only in plastic additive, but mainly on POPs. And what we have found in the skin biopsy obtained from this organism, we have found a very high concentration of some specific congeners that are related to microplastic and that are also related to the sea surface. So again, PCB and skin biopsy of these animals can be informed regarding the ingestion of marine litter. But probably the most important chemicals that reflect the transfer of chemicals from the plastic to the animals is represented from polybrominated diphenyls. In particular, if you explore in the different animal analyze the concentration of the different congeners, you have to focus the attention on these particular congeners that are the most important component in terms of plastic additive. So again, the key message is that if you consider the microplastics as a carrier of chemicals, if your main question is to define the potential impact on biodiversity, you have to search these chemicals in the tissues of the organism that you study, and that will be the second part of my talk. But I would like just to leave you with this very important concept that I have already touched before. A lot of these chemicals that can be absorbed from microplastic or even can be leaching from microplastic are endocrine disrupting chemicals. So that is a very, very important topic to focus both in terms of marine biodiversity, but also in terms of impact on human life. And this is the end of my first part, Tommy, and I will leave the second part for the next section. Thank you very much for your attention.
Thank you, Cristina. Thank you so much. In fact, if you want, I think that you can move to your second intervention, because I kept my part shorter and I presented the overview of the monitoring approaches.
Okay.
So you can dig into the specifics of biota sampling and microplastics
yes,
assessment.
it's a great pleasure. In order to introduce the second part and to be less boring, because I think I was a little bit boring, I will show you a video. And Tommy, you are familiar with this small video that, just a moment, I need to search it. That is represent the activity, how you have to work when your goal is to try to monitor the impact of marine litter on biodiversity. It is, sorry,
Cristina, don't forget to share your screen once you find the video.
Exactly, I forgot.
Okay.
Yeah, just a moment. You see my screen now?
We do.
just to wake up all of us a little bit, because otherwise we'll be boring. And no, it's my great pleasure to show this spot that describe in a very synthetic way what we have done in some activity of the Plastic Busters MPA project. And I will invite Tommy to share with all of you maybe the link from the YouTube large movie that we have produced and present in the Athens conference. And I think they can give a more wide idea of we have working in this. And as mentioned from Tommy, one of the main topic, the idea that we have in the project, but even on our group of research, is try to define the potential impact of microplastic on biota. And in particular, to try to define what can be the impact on the Mediterranean marine life. We have already touch this subject, so I don't come again on this. We know that there is different kind of interaction between marine life and marine litter, from the ingestion, entanglement, habitat degradation, and native species. We know also that a lot of our charismatic species are undergo to the ingestion of marine litter in Mediterranean Sea. But as ecologists and ecotoxicologists, we need really to understand this question on two different points of view. The first one is to define methodology that can really inform us about the impact of marine litter on the Mediterranean species. But on the other hand, we have to enforce this science policy interface. And so we need to support the governance at Mediterranean level in order to improve the idea of bioindicator of the impact of marine litter on the Mediterranean biodiversity. And it is I think the great goal that we have tried to achieve in our activity. Very briefly, so I don't come back again on this story, we have in the last decades studied a lot of the impact of marine litter on the several species, and particularly we have started with the most difficult one. We have not started with mussels. We have started with the large filter feeder species that we have in the Med, and we have confirmed that during the filter feeding activity, the species are undergo to a massive ingestion of microplastic that can produce several negative effects on the species. And we have the ability to use both stranded organisms, but also free-ranging organisms, as you have seen in the photo, and we see later on using the skin biopsy approach. So our, I think, idea was try to define the real impact of microplastic on the filter feed species, because definitely we strongly believe that can be some of the most exposed species worldwide, and even in the Med, to the ingestion of marine litter. But as a Mediterranean citizen, we strongly believe that one of the charismatic species in the Mediterranean Sea, such as the caretta, can be used as one of the most important bioindicator species that we have in the Med. And here we have already published a lot of data from 2013 until the last years, in which we reported that more than 70% of the caretta present in the Mediterranean Sea reveal high concentration of marine litter and even microplastic. And as support from the Marine Strategy Framework Directive, and of course, from the IMAP indicator of Barcelona Convention, and later on, Christos, I think, underlined this point, this species is the candidate indicator to define the impact of macroplastic in the Mediterranean Sea. But if you're talking about the impact of biodiversity, obviously, we cannot focus only one species. You have to analyze a wide range of species that can really reflect the entire negative effect that macro and microlitter can generate on the marine organism. And we have, as group, produced a lot of information since 2015 on the impact of microplastic in the large pelagic fish, the most important on the economical point of view, such as bluefin tuna, as swordfish, but even we have confirmed and studied one of the most important aspects that Tommy have already focused, extremely important, the potential link of microplastic and seafood safety. That is very, very important aspect. And again, unfortunately, Francois is not here today, but I would like to enforce a message that normally we live. So we strongly believe that the potential impact of negative effect from seafood sources in the Mediterranean Sea is very limited. And so when we focus on the impact of microplastic on fish species, is not to define the impact on human, because when we eating fish, normally we remove the gastrointestinal tract. So is not this the topic. The topic is more in terms of impact on the biodiversity than on human. As mentioned from Tony, the impact of microplastic in human is more related to the inhalation than not to assumption from food product. And it's, I think it's very important to underline in a Mediterranean context, because a lot of our economical activity are related to fishing and aquaculture. So we have not to demonize this product in the Med. I'm really convinced of this point, and I use all the time to stress this. But even is another story. If you're talking about the potential impact of plastic and microplastic on marine organisms, there is a lot of evidence, both in terms of lab work and in terms of field work, that, for example, fish species are strongly exposed to ingestion of marine litter, and that can have a lot of negative effect that can be more related to the physical effect, that not the chemicals. And we have a lot of information concerning this, but not also in lab. We have a lot of information concerning that a huge number of edible species analyzed in the Med reveal concentration of microplastic. So for example, or this wide range of species that are from bentonic, pelagic and demersal, most of them revealing occurrence of microplastic that in ranging from 45% in Sardinia to approximately 8% to Lucius. So that means that the different species in the Med are exposed to the ingestion of marine litter that can produce a negative effect on the species, but no negative effect on the last consumers that can be the human. That is just very, very rapidly, because Tommy said me be rapid. So the point is, we know that most of the Mediterranean species are exposed to marine litter. So how that can be really served also in terms of methodological approach, and we will touch a little bit the subject, but also in terms of supporting governance. So how the study of the impact on biodiversity can be really important in terms to define the quality of the marine environment. And we are very proud, myself, Professor Skoulos, Eleni, to say that we have worked all together in the last decade. Tommy, this is a decade of activity that we have, so we have to, to make a celebration of this, on this idea, on this dream of the Plastic Buster initiative that was launched approximately 10 years ago, and was support from the United Nations, UNEP, the Union for Mediterranean, and finally with important economical support to European Commission. And the idea was to binding together the south and the north of the Mediterranean Sea with the same dialogue in terms of monitoring activity. We have to use the same harmonized approach, mitigation activity, and supporting of governance. And so the idea was launched on this very important consortium. As I have already said, the main goal is to have covered the complete cycle of marine litter from the diagnosis to the mitigation. And we have worked mainly on the marine protected area that are the sentinel of the quality of the Mediterranean environment and the Mediterranean biodiversity. But what Tommy asked to me is to stress how is it extremely important to use an harmonized methodological approach to define the impact on biodiversity. And we have worked a lot on this concept in the consortium with a lot of strategic work and intercalibration. The first one was to define really what can be support as the good bioindicators in terms of occurrence of marine litter from the wide range of information that we have, and in terms of field data, in which, as you can see here, we have new enters for using as potential large invertebrates indicators, such as the sperm whale, that are the most exposed species of vertebrate in the Mediterranean basin. From all these, I can say, scientific consideration, we define this table altogether in the consortium, in which our idea is to define the impact of biodiversity, working from organisms that ranging from local scale bioindicator, such as Mytilus galloprovincialis, from large scale bioindicator as the charismatic species fin whale, and all these different bioindicator species can really represent the health status of different compartments and even the different scale from local scale to wide scale. So that is the approach that we propose in the project, and we implemented the different area. But one of the other novelty, and is one point that Tommy had focused very much, really we believe that our project have developed a very comprehensive new methodology that support the marine strategy and the IMAP indicator in one of the main questions that we have in mind. Does really the all ingestion of marine litter, as we support from the marine strategy framework and IMAP, can represent the answer to define the health status of the organism? And we can say that is not enough. It's not enough because in order to have a complete assessment of the potential impact on the biodiversity, apart to use a wide range of organisms, just to give an example, in the plastic buster, we have analyzed 45 different bioindicator species. You need to have more information. The first one is really the most critical one, important one, in which we understand the ingestion of macro and macro litter for the target species. So definitely all together we agree that is very important aspect. And for this we define an harmonized methodological approach in the consortium. But as we say in the previous presentation, the plastic can transfer chemicals such as POPs, such as PBT and plastic additives. So definitely we need to define how this chemical can be transported from the plastic to the tissues and measure this in order to define what the last potential negative effect. So define a series of biological endpoints that we can define as biomarker of omics technique that really reflect the health status of the organism. All this methodology can develop in the consortium, both in commercial species and endangered species, We have defined a toolkit that we can share with all of you. Tommy can share with you the toolkit. And we are preparing the final protocols in which all these concepts will be conscious represented. Of this information obviously come from the capitalization of the previous project and the main pillar Mediterranean level. And what we would like just to show you that, as mentioned from Tommy, we have worked a lot in order to have a kind of calibration procedure, for example, for the first step, ingestion of marine litter in marine organisms. We have published a paper in which we define all the digestion procedure that you need to do in order to define the presence of marine litter in a fish, gastrointestinal tract, or in mussels. That is the most valid method, and even all the characterization procedure of microplastic that I have already described from Tommy. That is the basic stuff. But a part of this, we are going forward to apply a more complex procedure in which we define the toxicological effect with a lot of new techniques that we define, omics technique, that can be realized from specialized labs. So we have a multi-level approach to define the potential effect on biodiversity, from the basic ingestion to the define of molecular variation on the organism. And this approach can be applied not only in the invertebrate or fish species part, particularly also in endangered species such as, for example, the sea turtle, both in the stranded and in hospitalized sea turtles, in which we have applied this threefold monitoring approach. And even as I stressed before, that is the most attractive approach for me, define the potential impact on endangered species such as cetacean, using both kind of biological material that we can obtain from stranded organisms, but also from free-ranging organisms using the skin biopsy approach. Just for give you an example, in stranded organisms, we have developed a new prototype to isolate macro and microplastic from the gastrointestinal tract for large cetacean, and even you can analyze the presence of plastic additive in tissues. On the other hand, as you see before, we definitely use the skin biopsy approach as a fruitful system to define the potential transfer of chemicals from the microplastic during the filtration activity to the tissues. And also we have developed a new merging techniques such as omics to define the dianesis of the species. So that is the end of my talk. I hope to give you more than technical data, a kind of aspiring approach, how we can move to define the impact of marine litter in marine biodiversity. And thank you for your attention.
Thank you, Christina. Thank you so much. Really, a lot of information, a lot of interesting facts and figures, and always very fascinating to navigate, you know, the world of microplastics pollution with you. And of course, you are a very passionate woman. So if you took a little bit of more time, I hope that our audience will forgive us for that. It happens to me too. So please have a bit of more understanding with passionate women.
Thank you both. And actually, we'll extend the duration of the webinar with the understanding also of the interpreters and the audience. And we move to a third passionate woman.
Indeed, we do. And we would like to invite Eleni to take the floor.